session.
Yes.
And that's all from my side. We have 1.5 hours or 2 hours?
Ma'am, 2 hours.
2 hours?
Yes.
Okay. So please, you can continue, Shubhangi.
Yes.
Is Purnima available?
Yes, ma'am, she is there.
Okay, fine. Thank you.
So, good afternoon, everyone. So our today's problem is linear regression using AI&ML. So I'm sharing my screen.
Yeah, Durgesh, please make Purnima co-host. And as we did, good afternoon. And as we did last time, we will keep you, you can unmute yourself or participants so that whenever you have a doubt, question, you can ask that. But please try to maintain your mic in muted mode to have a, good Shubhangi, you are unmuted.
Yeah. Yes, ma'am. Yes. Good afternoon, everyone. So we'll be today doing linear regression using AI&ML, and the data set is already provided to you in your day 3 folder that was used for solving the problem of linear regression using SVM. That was the Algerian forest fire data set. So I have also uploaded this data set in your day 6 folder also. So you can download that folder and keep it in your drive. The folder, please do not access on that shared drive. You can use your own drive for using this data set. So here I have already kept the data set, and I'll now create my Google Collaboratory file. So I have used more option and then open the new Google Collaboratory file. So I'm renaming it as regression using AI&ML. Okay, so as we know that initially we require to import certain libraries to work with. So I'm importing import pandas as PD to read the data set that is provided in CSV file. Pandas as PD. PD is the alias. Then after that, NumPy is aliased as NP. So import NumPy as NP, and then matplotlib.pyplot as PLT. Import matplotlib.pyplot as PLT. After this, we require that our drive is mounted so that we can read the CSV file from here. So let this cell run. I hope that dataset is kept where you are working. Okay, so here I'll mount my drive. Click on this symbol for mounting. Connect to Google Drive. And now the drive is mounted. Here drive would be shown. So it's taking some time. After this, till that time, I'm writing ds is equal to pd.readcsv. And then please paste the path where your data set resides. So I have it in my FDP folder. So I'm pasting this path. So I hope till here everything is clear. After this, we will see what this contains. Initial few steps will be same like previous one, but we will follow a few of the visualization technique and then create our own model. So for that, we require some processing steps to see the data and to clean it. So those steps would be repeated. So here we can see that various features are present. So it has 14 columns and 122 rows, and you can see it by increasing this and see each data over here. So this is about this data set. This was already explained. So after this, what we require is to read the attributes, mainly the attributes. So we will read attributes using keys. df dot keys. Here we have 14 columns, so all keys would be present over here. So as we know that year was not necessary for us to keep it, so we will drop it using drop. Df is equal to df dot drop and pass the column name that we want to drop, year, and then provide the access as 1. So now we can check the shape of df using df.shape so that we can see that whether this was dropped or not. So we have 13 columns right now. So year has gone, and now we can print the df.keys. So we can see that yes, year is right now not present, but we require that here spaces are present over here. So these spaces are to be removed so that we can begin with our problem. So for this, we have df, we have what we have, that we can strip this thing, column thing. So for this, we use a strip function df.column. So I am keeping it in df.columns. df.columns dot str dot strip. This will remove these white spaces present in these attributes. Now we will print df.keys, the keys which are now removed with the white spaces. So we can recheck it. Sorry, it's keys. We can recheck it that yes, these things are going correctly. Okay, so I'll wait for a while so that you can pre-process it till here if someone is left behind. If you have done till here, you can write it on chat box. Yes, I will share the notebook. I will surely share my notebook. Okay. So let's begin. One of the important thing during research work is how to see the data, how to analyze the data, to visualize it, or to see how many attributes or features are present, and then how many values are present in particular feature, or the probability that if we can say that this number of fire thing is present in a particular attribute, then we can easily analyze something. So for this, exploratory data analysis is performed. For that, we are doing a few of the tasks, like we are counting the values in particular attributes. So let's calculate how many attributes are present in month. Sorry, month is having how many different values. So let's write df dot month dot value counts. Value counts. So it says that the month 7 is having 31 values. It can be fire, it can be non-fire. Month 8 is having 31 values. Similarly, we can see for features, sorry, temperature. df dot temperature dot value counts. So it says that 24 temperature value is having only one value present over here. 31 times the temperature was repeated in the rows. So this is about seeing the count values. Now, as we have seen that fire and not fire class was having some white spaces present in that. So to see that what classes had in it, we will print df.classes. So it will show how many values were present in classes. So we can see that it is not actually only two objects, fire and not fire. It has white spaces. So there are 6 different objects. So for this, we have to remove the white space. And for that, we are creating df.classes is equal to df.classes.str.strip function, as we have used it, and then see that what was present. Now we can see that fire and not fire is only present. So till here, everything is clear. Okay, so we will begin with our exploratory data. Right now, I require label encoder to give labels to our classes. So from sklearn, sklearn dot pre-processing import label encoder. Import label encoder. This is used to give 0 or 1 value to the classes, that is fire and not fire. For this, we have to import label encoder from sklearn.preprocessing, as well as we require to import preprocessing from sklearn. So from sklearn, import preprocessing. Then we have label encoder. Then we will use label encoder is equal to preprocessing dot label encoder. Label encoder. So this is kept in label encoder thing. Then after that, what we have to transform is our classes attribute. So for this, we have in df, use the name of the attribute that we want to transform. Classes is equal to label encoder dot fit transform. And again pass df classes. Okay, so let's see that whether this is correctly done or not. So for this, we will see set df dot classes, and it is given as label as 0 and 1. So right now we will give store the keys value inside a keys variable df dot keys, so that we can use this further for you for taking the values inside present inside it. So now till here everything is done. I'm waiting for 2 minutes so that if anyone is left, they can complete this thing. Okay, so let's begin with plotting one of the graphs, bar graphs. So for this, I'm using group by. Let me first of all write, and after that I will explain what it is doing. Here I am passing two attributes, that is one is the month and another one is classes. Fig size I am setting as 10 and 5. And then I'm giving font size as 14. And I will set title as average class of probability in different months. And in x-axis, month would be displayed, and in y-axis, classes would be displayed. Ax dot set x label ax dot set y label classes. Font size as 15. So you can see here, let me make it small. So you can see over here that here months are present, and the number of times these classes were repeated, that is present over here. So this blue color shows that how many times one class one means not fire was occurring. So we can say that if six, the total number of count of six was in month of six was 30. 30 times 30 was present. So here, more than 50% means that approximately around 17 to 18 rows contain non-fire instances. So here, like in month 9, there were overall 30 instances present. So in these 30, majority of them contain 1. You can visualize it in your data set also by opening the CSV file. You can see this. So similarly, we can do it for any other feature also. We can see for temperature thing. Temperature. So you can see it for temperature also, that how many instances are there that contain 1. So you can see that these many number of temperatures are present, and in 37 there would be possibility that there is only fire present, so there is no blue line covering over here. So that code was actually calculating the average number of times how that data is getting repeated. So so please try to do this, and then we will proceed further. Okay, so let's begin. Till here, any problem? I hope till here everything is done. So you can visualize the results of the training using graph also. Here it was only to show how data looks like, that practice can be done. Line number 20. This was. Okay, so what our next objective is? Our next objective is to store the X and Y values. X values, what features we are going to train or test, and then the Y value that we have to form that is the output vector. So our input vector and output vector that we have to form. So for that, which attributes we want to take, that is up to us, and we can decide it according to our problem, what we are performing. So right now I am trying to take um, many features, approximately 9 features I am taking. So, and I'll be using the output vector as temperature. So here I have X is equal to df of, first one is, I'll be taking randomly from here, like RHWS rain. These features I am taking and predict using this. I'll be predicting what temperature would be the output vector. So in X we are storing RHWS. Then another one was the rain. Then let's take FFMC also. TMC. DC. ISI. DUI. And FWI. Sorry, S is okay. So this is the input vector. Then in Y, I will store PF, temperature. Let's see what Y has. So it has Y. So it has temperature values. After that, we require training and testing split. We require train and test split. For that train test split, we'll have to import from sklearn dot model selection. So here we will import first of all train test split. So from sklearn dot model selection import train test split, and then store this in then we will divide it into the train and testing part. So X train would be containing our train rows, train comma X test, then Y train, and Y test. And we will use train test split and pass that we have to split it. That was the original X and Y values. And the testing ratio will be given as 0.2 or 0.3, whichever you want to take. I am taking test size as 0.3 so that 30% of the data goes into testing part. And random state can be given anything. So I'm giving it as 34. So after this, we will have to normalize the data. So for that, from sklearn dot preprocessing, input standard scalar and scalar is equal to standard scalar function. We have stored it in standard scalar. So this is scalar variable we will use to fit transform. So here what we have xtrain. For this I am using variable xtrain underscore scaled to store the scaled values. Then we have scalar dot fit transform dot fit transform and pass xtrain values. Similarly, we have to scale ytrain also. So for ytrain, I'm using ytrain underscore scaled is equal to scalar here I have ytrain. Similarly, we'll do it for testing set also. X test scaled and then X test. Here I will name it as Y test scaled and Y test. Okay, so till here, I hope everything is clear. I am waiting for 2 minutes so that you can write it. If you have done till here, you can write it on chat box so that we can begin with. Should I wait or move ahead? Okay, so let's go ahead. So now we will try to build our model of ANN to perform the regression task. So For that we require dense and sequential. So here I would be importing dense from layers, keras.layers from TensorFlow dot python dot keras dot layers. Import dense, and after that what we require is sequential. So from TensorFlow dot keras dot layers python models, we will import sequential. Sorry, it is models. Okay, so we will use keras dot models dot sequential to build our model as we have done in our previous lab. After that, we will add the dense layers to it. First of all, we require what? Input. The input vector is of shape 9. We were passing 9 features into the input into the model. So we would require input shape as 9. So model dot add keras dot layers dot input layer and input shape is equal to 9. So we have given our input into the model. After that, what we require is making the hidden layers. So for that, we are using dense layer model dot add keras dot layers dot dense and units is taken as 32. Activation is ReLU. Model dot add keras dot layers Next time, we will create our dense layer with units as 16. And again, activation would be used as ReLU. And last output layer would contain model dot add keras dot layers dot dense activation we would be using is linear in the output layer. So we are done with this, creating the, okay, so here sorry. From TensorFlow, import carrots. After that, we can print the model summary. So we can see here that 865 parameters are only required because we have made a small model. So it does not require much of the parameters. So after that, we will begin with compilation of the model and then fit the model. So please try to make the model, and I'm giving you 2 minutes, and then we will begin with compilation. If till here everything is done, you can write yes or done in the chat box. Okay, so we will begin with the model.compile. So model.compile, loss that is provided here is MSC, optimizer we can use is Adam, and matrix MSC, comma, MAE. Then in history, we will store the model.fit to plot the graph that can be required for future. History is equal to model.fit, and we will pass the scaled values that was stored, and it was X train and Y train scaled. So this is equal to 1. And we are splitting the validation set into 20%. So validation split is given as 0.2. So try to please write this model.compile and fit. Till here, everything is done. Please say done or yes if you are done with the. I'm waiting for 2 minutes if people are training the data. So till then, I'll wait because not much of the people have done till now. Okay, so we will try to plot the graph now to see how training was done. For that, we have stored the training in history. So that variable we would be using. Print history dot history dot keys PLC dot plot PLC dot. We'll be seeing loss and validation loss here. So PLC dot plot and then pass this for validation to print the validation. After this, I'll be giving graph title, PLT dot title, graph of model loss, and then set the X and Y label. So PLT dot X Y label is as Y label is given as loss, and PLT dot X label epoch. PLT dot legend frame and validation. That would be printed on upper right corner. And location I'm giving as upper right corner. Upper right. Sorry. So although loss has decreased, but still there is a gap in between. So you would be knowing about overfitting and underfitting in your further labs. So I won't say much about it over here. So you can once see this curve and see the gap in between this. Although this should come near to the training, the validation thing, the validation orange curve should come near to the blue. That is the good saturation that is called. So that we require to be obtained. So here some of the gap is present. Now let's plot MSE. Validation MSE and graph of in similar fashion this would be plotted. So it also looks like same. So after this, what we want to do is we require to predict the testing set. What the predictions are done, that is our main objective. So for that, what we do is model.predict, use model.predict function. So for prediction, let's see what predictions are done and how they look like. Prediction model dot predict X test scaled after this. Yesterday someone was asking that if we have transformed or we have scaled or normalized the data, how can we get the original one? So for that, inverse transform is used. So we would be using that also in this thing, so that we can see that what the difference actual difference is present in original, the ground truth and the predicted result. So here scalar dot inverse transform y-test scale After this, we'll see the first object. So what it is printing is 25. Let's see, predict what the actual result was. Predict temp is equal to scalar inverse scalar dot inverse transform prediction. So we are inverting the prediction that we have done, and then predict the temp value. So it is giving us nearby value, although not that much similar, but temperature is like 25. Actual temperature is 25 and the predicted one is about 27.8. Marginal small difference is there. Yeah. That is what we should decrease the difference between these two values. That is the main objective of training the data, so that we can get the result that is close to the actual one. So let us once see all the predicted results, how much they are close to each other. So for that, we will plot the results. So PLT till here, I'm giving you time. After that, we will again see what how to plot it. So please do it. If you are done till here, please write done in chat box. Okay, so let us plot the actual and predicted values, how close they are. So PLT dot plot actual underscore temp. PLT dot plot predict temp, this variable, and then PL will be given title as graph of model loss, and set the y label and x label. PLT dot y label and x-axis is having the number of samples that were present for testing. And in legend, we have to show the color that we have used. Actual and the predicted one. Then we have these place where we have to give this legend, that is in upper right corner, and then show the plot. So we can see that here difference is more in predicted and actual one. In this sample, there was lesser difference. Here also less difference was present. So here like this, you can see that what was the predicted and actual result were close enough, or they were separated too much. So after this, we can also check the quantitative results in terms of MSE, or mean absolute error, that is calculated the difference between the actual and predicted values. So these two metrics are used for seeing the how good our model is performing. So from sklearn library, we will have to import mean squared error to find out what the value of mean squared error we are getting in this model. So from sklearn dot matrix, import mean squared error and print our mean squared error is mean squared error is copy this and pass the values, that is the prediction and the y-test scaled value. So we are getting 0.399580 as our MSE. We can try to reduce that also. From next metric is mean absolute error. absolute error. Prediction, and we will pass prediction and y-test scaled. So here we are getting 0.50968. So this was the quantitative result that we have got. What Now I'm waiting for 2 minutes to complete. You can complete this thing, and what you can do is, as an exercise for now, you please try to change the features that we have taken as an input and train the model again and see the difference, what difference you are getting. Note this difference when we have taken 9 features together, and then like I'm getting 0 point, you might be getting different result. So note those results, and then try to use a different set of features, and then train this model again and see the results what we are getting. So please try to do it right now, and then tell that what is happening here. It won't take much time. You have to only change this x value here, x value, set whatever you want to set the feature input features to our model. I'm giving you 5 to 7 minutes to do this task, and see what the difference is, so that you can analyze what these features are. Because the final result mostly depend on the features that we are taking, how much useful those features are. So try to do this exercise. And remember, the number of features that you are taking as an input, please try to change the input shape accordingly. Here, like we have taken 9 initially, so according to that, you have to change the input features. Otherwise, you would get error. So if someone is done with this exercise, you can tell the difference, what difference you are getting in your result.
Participants, if you have any questions related to your even research issues, it's not only the exercise that we are doing with you. Basically, we wish to have this as a dialogue so that there are several questions that you ask during, during the lectures. You can ask here also if you have any questions, any problems, any issues related to your own research problems. So please feel free in making and talk to us, and please help us making this session very interactive. Uh, she is doing great, but I think that uh, there's something which is important. So, Sarvan Kumar Vishwanathan ji is asking, I need to visualize all data with multi-graphs with multicolor. So, if immediately you can do something with that, Shubhangi, that would be great.
Ma'am, it all depends on his problem statement. So, it it depends on that problem statement. So, with this data set,
color, graph color.
Graph
Not based
color
on
is,
problems.
ma'am, here.
See, just go through the question, and I think
Okay.
you will be able to understand.
Okay,
Yeah.
ma'am, I'll try to do it at the end.
Yes, yes.
Sure.
If not right now, we can definitely tell them. Yeah,
yes,
it's something very simple. It's
yes, ma'am,
only coloring. Yeah, that's what. Like
yes,
it's a simple exercise. Yeah.
Okay, so you would have tried it. So now we will begin with another problem. So I'm creating another file, collaborative file, where we will doing next problem in CSV file, that the data set that we have used in our previous lecture of ANN yesterday. So the data set that was provided yesterday of human activity recognition, so that data set would be required over here. So let's rename it as activity dataset regression. So for this, we will again have to mount our drive in this notebook. So let's mount the drive. Till that time, I am importing pandas library. Import pandas as PD. and then read the data set. This is the same data set that we have used in yesterday's lab. If you do not have, please access the day 6 or day 5 folder that we have train and test two different CSV files. Those, please keep that CSV file in your drive and then read it. So this file contains human activity recognition data. I am reading it in train TF. Read CSV and then pass the path where this data is. And then print the first 5 rows using head train dot train df dot head. Okay, so we can see that there are 5 rows and 563 columns present in this data. So we would be requiring only few of the some features to train, and we will be having the one of the feature on which that would be required as a Y label. So for this, we have first of all we have taken training data. Now would be taking testing data. So we have test.csv as a separate file, unlike the last file which we have splitted through our notebook. Here we have separate files. So test df pd dot read csv and then test underscore clear dot head. Sorry. So right now we do not require few of the columns that are not required for our training purpose. So for those attributes are to be dropped. So for that again we'll be using the traindf dot drop and pass those column names that are to be dropped. So here we have x train df dot drop and columns would be given as the last one, the subject and activity. Subject, activity, and angle. Let me take this one, angle Z gravity mean. Angle Z gravity mean, because this would be taken into the Y label. So we are taking Y is equal to train df as the column named as angle Z gravity mean. This is one of the attributes that is passed into the Y label. Similarly, for X test and Y test, X test, we will have to drop similar these same attributes. So here we are taking test df dot drop these columns and Y test is again angle Z gravity mean. Df angle Z gravity mean. Till here, please do it. I'm waiting for a while so that if someone is left behind, they can complete the task. If you are done with till here, you can write it on chat box. Uh, should I proceed or should I wait? Okay, so we will now begin with our model train test split and then building the model. So here from sklearn, dot model selection, import train test split, x train comma x val and testing, training and validation of y comma y val. So we will be splitting the data set into training and validation set. So we'll be giving the test size as 20% for validation. So for that, we are using the training and splitting. Since here we have the testing set, testing CSV file as a separate file. So here we can split it into the validation thing. So here I have train test split, pass the x and y values and the split ratio. Test size as 0.2. And then we will build the model. This time, when we have dropped the column, initially we had 563 columns. But now since we have dropped 3 of the attributes, so we will be having 560 as an input features passed to our network. So from TensorFlow, import Keras model that we'll be using is sequential model. Model equals to Keras dot models dot sequential, and add the layers into it. Model dot add Keras dot layers dot input layer, input shape is given as 560 this time. Model dot add dot layers dot dense with units as 64. And activation function ReLU. In the next dense layer, I'm using 32 units. And then I'll be using output as 1 unit. Last dense layer is having 1 with linear activation. So run this cell and then print the model summary. Model dot summary. After this, what we used to do? What we used to do after building the model? We have to compile it. So for model compilation, we'll be passing optimizer and loss. Model dot compile. and using optimizer from Keras dot optimizers dot Adam and set the learning rate as 0.0001. Loss is taken as MAP. And matrix as MAP. Model history we have model dot fit x trained and y trained. Validation data will be giving the validation data that we have that we have taken as 20% split of the training data. So here we have x val and y val storing those values. X val and y val. Yes, these are the values. So here we'll be training to 30 epochs, or 30 epochs will be training, and batch size is taken as 16. So till this training, try to do this. I'm giving you 2 to 3 minutes. Build the model and then compile it and train it. After that, we will proceed further. If you are done till here, please let me know. Please write it on chat box so that we can proceed further. Please write done if you are done with these steps. Should I proceed? Okay, so let's begin with seeing how this plot looks like. So for this, we will use keyboard matplotlib.pyplot as PLT. Model history, model history dot history, and AE, and save this for val MAE. Sorry, MSE I have taken. So I'll be taking MSE. MSE and then MSE here. And epochs that were runs were of 30, range of length of train, MSC. Then we have PLT dot plot epochs train, MSC label is equal to training val MSE and then saving and validation of MSC. PLT dot title training and validation, and plot the legends. Legend. So we can see that values are actually close enough to each other, and that's why we are very much close to each other. So that's why we are only able to see a validation. However, we can change the configuration and see that there can be a small difference in these values. So you can try that out. It would be have clear view of training and validation, both things. So after that, we can evaluate the model. We can evaluate the model using model dot evaluate X test and Y test. test data. So here we are getting 0.0005 MSE value. So your test data is having X of test dot ilog 0, all. Test data dot shape. We'll be printing the shape of test data. That would be giving us the number of attributes that we have passed. We are having 560 attributes. Import numpy import numpy as np, and then predict these testing results. Model dot predict np dot array numpy array, and then pass the test data and reshape it to 1,560, otherwise it's going to give you errors. And print the ypred value. And the actual value is y test so it is close enough. And then what we'll try to do is we'll be trying to plot the graph, how much close these predictions are to the actual result. So like we have done it in our previous file with the forest data sets, in similar fashion we'll be plotting it. So here we have plt.figure fig size. Fig size is equal to 12 and then 12. Then plt dot plot y test and plot the prediction. Plt dot plot prediction and set the title and labels. We're not done prediction. Equal to model dot predict. So we'll be writing the title here as prediction graph. And by labels plt dot Y labels. We were having angle named as angle Z. Yeah. Angles and gravity mean features, and X would be having samples, the number of samples that are present. Samples in test data. So in legend, we have PLT dot legend, actual and predicted, comma predicted values. Location provided as upper right, and show the graph. PLT dot show. So we can see that the predicted values are close to each other. Actual and predicted one are close to each other. So you can see it. The thing that we wish to tell you is that when we had smaller number of samples in the data set, or when features were small and the data set was not that much big, at that time our results were not that much good. But when we have taken a data set having a large number of samples as well as large number of attributes, at that time we are able to predict better results. So that was the main objective of today's lab, for using both of the data sets, and to tell you that how this regression works using ANN and how these features reflect the results. So this was all from my side. This is all from my side. And if you have something, then we can talk about it. The graph thing that someone has asked, we'll be giving that. We'll be providing the code related to that by today. Do you have any queries? We will share the notebook in the shared drive in day 6 folder. I will share it now. Okay. The notebooks we are sharing in the shared folders, so you can view that. I'll be uploading my both of my these Golab files by today itself.
Hello?
Yes, ma'am.
Yeah,
Yes,
Shubhangi.
yes, ma'am. We have done today's lab.
Yeah, yeah, yeah.
Yeah.
So thank you so much, Shubhangi, and for this excellent lab session. And I hope participants have enjoyed it, and they have also done all these exercises with you. So, I would like to thank participants as well as Shubhangi, another young researcher from our lab. So this is again, daily. I mean, this is a good thing which is happening with us daily, that we are seeing you all coming up in such a wonderful manner. Thank you, Shubhangi. So, and also thanks to all participants, to our Asia Connect staff, and see you soon in the next session. So don't forget to join, because the next session is very important for. Because there are a couple of things. Yesterday also you were having questions, so today you will get answers of those questions, and to move further, this is important, right? So see you all at 6 p.m. So take care till then. Bye.